All right. I think we'll go ahead and get started here so that we can stay on schedule. So, very excited in a lot of ways to continue as sort of part two of panel discussions that we began yesterday on topics around essentially planning resilience to extreme heat. We're going to continue that conversation today. We got some fantastic perspectives you're going to hear. And we're essentially going to ask the same questions that we asked yesterday, same structure. I'll turn to each of the panelists, give them 5 minutes to talk about themselves and the work they do at their organization and how it really engages around topics of heat resilience. Then we'll go into those 3 questions we heard about yesterday, asking each of them to describe a challenge or opportunity or both in this resilience space. Then a second questions that sort of engage, what requests do they have? How would they want to engage more around some of the science dimensions? Could be climate science, could be other aspects. What are some of those information needs in that transdisciplinary space? Then we'll go to that elevator pitch kind of question around what are the opportunities to leverage, inspire, and make rapid change. And then I'm hoping, just like yesterday, we're going to have a lot of audience questions. I suspect we will. We'll try to leave time to get to all of those. We got about 75 minutes for this, so we'll break around 12:20 or so, maybe a little bit earlier. So I think with that, I'll get out of the way and turn to first panelist to the right of me, Dan, to talk a little about himself and his work.
Okay, thanks, Radley. So I'm Dan Metzger. I work at the Sabin Center for Climate Change Law, and we are a legal research center that develops techniques to combat climate change and to think about legal challenges in this space. In my role as a Smart Surfaces Fellow, I work with an organization called the Smart Surfaces Coalition, which is a group of 40 national and international nonprofits that are focused around a cluster of adaptation technologies that we call smart surfaces. And as we use the term, that refers to passive technologies and design principles to mitigate the effects of climate change. It's a lot of things that folks in this room are very familiar with and we've heard about already in the last couple of days. Cool roofs, green roofs, rooftop solar, expanding and protecting urban tree canopy, porous pavements, reflective roads, those sorts of things. The legal work in this space involves looking at building codes and zoning codes and the opportunities and challenges that are there, developing model alternatives and ways to work within existing frameworks. It also entails looking at the intersection between federal and state law with local law and some of the interesting questions that come up there, and again, identifying opportunities in that space. One project in particular that I'll flag is our Cities for Smart Surfaces initiative, in which the coalition's partnered with 10 cities around the country to produce some very granular custom benefit cost analysis tools. And the inputs for that are city data, local climate modeling, and the output is quantified benefits of smart surface implementation across a broad scale. So thanks for being here. Look forward to the questions.
Great. Thanks, Dan. All right, Charlie, over to you.
Okay, good. Excuse me, Charlie Viemeiseter. I'm with Con Ed. Been with Con Ed about 16 years now. I'm currently in a strategic planning group in a group that's called the Climate Change Risk and Resilience Group. And we're here in that position thrust into that by Sandy. Sandy really made the company understand that we couldn't no longer look at events that happened. Some outages may have occurred. We'll put in different equipment to maybe resolve that for the next time around. Sandy opened up our eyes that climate's changing. And because of that, we worked with a working group, external parties, the city, MTA, other entities, customer entities, to try and work out, well, what do we do? How do we do this? So we came up with doing a study in 2017. And I have to say, I got to, with this audience, thank Radley for all the work that he's done with Con Ed in helping us understand what climate science could tell us. And then I had the opportunity to tell him what Con Ed needed to know. And I'll get into that in the second question. So we wound up putting that together, that study. 2019, we came out, we took a look at what the science could tell us and translated that into information that our groups could use. Temperatures, heat indexes, flood levels, all of those things to try and understand what our equipment is going to live in the future and try and see if we can adapt to that now rather than when it happens. So because of that, we wound up also putting in a governance structure to make sure that the company itself understood climate change is a big impact on our company. We work in the environment, we live in the environment, we need to make sure that we are prepared for what that environment is going to put in front of us in the future. So we have a climate executive committee that I work with, our group works with, to try and keep them informed of where the science is going. We just, because of the work that we did in 2019 and our study and our implementation plan that followed that, the state required all of the New York State electric utilities to do their own climate studies and submit a resilience plan, which we all did in November of last year, giving a 20-year look ahead of what we think we need to do with some 5-year investments of what we need to do immediately to try and prepare for climate change. And again, we were using Columbia and Radley to help us through what that new science is going to be, because our first study was CMIP 5, this new study was CMIP 6, and one of the things that we saw that in this is heat came in a decade earlier than we anticipated in the first round. And that had a big impact for us. And I'll talk a little on the first question about that. So that's who I am, that's where I'm from, and that's what I'm doing right now. Thank you.
Thank you, Charlie. Roop.
Hi, everyone. My name is Roop Singh. I work with the Red Cross, Red Crescent Climate Center. And to tell you a bit about myself, I have to explain what this Climate Center is. Essentially, you might be familiar with the American Red Cross, and maybe the first thing you think of is blood drives. But the Red Cross is actually, and the Red Crescent, is actually a humanitarian organization, and it's a network of 191 national societies based around the world. So in 191 countries, tasked with being the organization that responds when there are disasters. And so I would say about 7 or 8 years ago, we started to hear more and more from our member national societies that extreme heat was becoming an issue. They started to notice that infants in neonatal wards in West Africa were being affected by very, very hot temperatures. In Somalia, people who are pastoralists, where they used to be able to walk barefoot across the sand, now their feet were literally burning when they were doing that. So really viscerally hearing from people around the world that extreme heat was starting to become an issue. And that was when we decided as the Climate Center that this is an issue that we need to focus on, given what we know about climate change and the fact that countries around the world are really not prepared for the extreme heat that we have even now and what's to come. So from that, we've sort of built out our extreme heat program that includes science, policy, and practice. So it includes a focus on understanding, for example, how is climate change affecting particular extreme weather events through our work with world weather attribution, so the attribution of extreme heat events. It also includes understanding when does heat become dangerous, what are thresholds for extreme heat in different countries, and how can we connect that to early warning systems. It also includes a lot of other things. So one of the things we notice is, especially in countries where it's already hot, people lack risk perception related to the risk associated with heat. They think because they live in a country that's historically been hot, it's not an issue for them. Whereas when we look at the data of heat-related deaths, that's not the case. So a lot of our work is also around awareness raising and behavior change communication. And then, of course, we're also working with cities, because one of the most important things that we've decided we need to do is ensure that cities around the world have city heat action plans so that they know what they're going to do each and every year when heat waves occur. So I can talk a bit more about those in later conversations.
Thank you, Roop. Now we're going to go over to Franco, and Franco gets a special privilege because we're co-PIs together on a project. So he asked if he could show a couple of slides that overlap with some of that work, and I said yes. So Franco, take it away with your intro, and feel free to wander over to the podium if you want to show a few slides too.
Thanks, Radley. Good morning, everyone. My name is Franco Montalto. I am an engineer. I focus mainly on water. I'm a practitioner. I have a company in New York City called E-Design Dynamics, but I'm also a professor at Drexel University in Philadelphia. And Drexel has partnered with Columbia and a number of other universities since 2010 as this consortium for climate risks in the urban Northeast, which is one of the sponsors of today's event. CC Run looks broadly at the impacts of climate change in cities in the Northeast. My role within CC Run, not being a climate scientist, is to look at the infrastructure impacts of climate change. And because my area of expertise principally is water, I've spent a lot of time looking at water and flooding and stormwater in particular. And that's kind of what brings me to heat, because as you all know, over the last 15 years or so, and I'm assuming you know because you walk around the city and you see green rectangles in the ground, right? You see bioswales, you see this whole sort of family of water management strategies that are decentralized and known as green infrastructure. This has been a sort of a seed change in the way we think about infrastructure, right? Doing lots of little things is believed to collectively lead to greater benefits at the broad scale than one big thing. And, solving water problems with big things is very expensive, where lots of little things can be tailored and adapted to local conditions. And so after working for a long time on green infrastructure from a water perspective, along comes COVID. And COVID, during the first summer of COVID, closed down cooling centers and malls and libraries and places where people would go for centralized cooling. And in Philadelphia, where I teach, there was a big interest in looking at decentralized strategies for providing heat relief in neighborhoods. And I saw this as an analog to green infrastructure, right? Lots of little things. One of the sort of principles or premises or perceived advantages of a decentralized approach is that because it's tailored, you can kind of get lots of co-benefits out of these lots of little things. And so we've been working on a block scale with actual residents to implement, and I guess this is where Radley permitted me to show you 2 or 3 slides. How do I do that? Is this a touch screen? There's no... Oh, there we go. Okay. Thank you. Okay, thanks so much. So we started working with community-based organizations and asked them which blocks have the greatest heat risks. And then Philadelphia has an interesting urban governance model called Block Captain. So it's a volunteer organization. Individuals volunteer to be block captains, and they are in charge of creating benefits on their blocks. And so we started working with them with a modular design for providing shade, but because we were also having extreme wind events, we didn't want these shade structures to turn into torpedoes, so we ended up mounting them to a bench. And because we wanted the bench to also contribute to beautification, we put in a planter. So it ended up being this hybrid approach, which is kind of analogous to the green infrastructure approach, where you get shade, you get aesthetic improvements, you get social opportunities, and you beautify a block. And not only that, we built these systems using residents of the block. So it became, because COVID, as you know, was not only a physical disaster, was also an economic disaster, and people were out of work. And so we trained individuals from the block to fabricate these planters, install them, plant them, and then ultimately, and this is an ongoing project, we've now installed hundreds of these, probably 500 of these in Philadelphia, monitoring. And we're monitoring urban heat, and that brings me to urban heat. So that's a long detour to say how I got involved in urban heat work.
That's great, Franco. And we'll circle back to talk a little bit about sensors and some of those needs in a bit. Okay, so I think as we go to question 1, maybe we'll stagger. I'll start this time with Charlie, so we go in a little different sequence. And just a reminder, don't feel like you have to stick exactly to the questions. Please jump in and comment on what you hear from others and reflect too. But yeah, the first wide open question, Charlie, tell us a little bit about some combination of opportunities, challenges in this adaptation to heat space.
So as I said, we have a climate risk and resilience group it's focused on this within the company to try and work out what information we can gain. And we're working with our engineers, trying to make sure that we understand what it is they need to know. So one of the things that we have in the company is a variable, we call it a temperature variable. And it's sort of equivalent to a heat index, but it focuses a 3-day look ahead. So what it does is you're taking the highest 3-hour average of the wet bulb and dry bulb temperature in a given day. But if I was to look at Saturday, I would take today's day, what that average is, I'd take 10% of that. I'd look at tomorrow, Friday, 20% of that, and then Saturday, 70% of that projection. That gives me a temperature variable number. And we've come to understand that when that number, based on historical events, when that number gets to a value of 86, we can anticipate that we're going to have a peak load on our system. Doesn't definitely happen, but it anticipates that you're going to have a peak load on our system that day. Because it's the strength of that heat wave that we're looking at, building up, creating an event that you know is going to be peak load. Peak load means we're going to be putting a lot of energy through our system, and to move energy takes, you create heat as well. So our equipment needs to be able to, extract that heat so that it can operate properly. If the operating conditions start to change and your ambient temperatures are different, your peak temperatures are different, it's going to have an effect on the equipment's ability to operate efficiently. We've built a little of that in the way we design our system, so if we lose a transformer, we have spares. It's not that, but it's also, our biggest question becomes, well, we can anticipate that, and we have things in place to address that. But as climate changes, how long is that heat wave going to be? Right now, I think on our heat index projections, baseline is we're looking at like 13 days of heat index over 90, right? That's historical. That was from 1981 to 2010. That's the historical value. Projections are saying by 2030, we're going to see 39 days where the heat index is over 90. So translating that into the potential that our temperature variable is going to be higher and higher, and for a longer period of time, because those 39 days, that's almost a third of the summer, right? So that's a big concern for us. Some of the things that we're doing right now in anticipation of that is we can't always determine exactly where our system may fail, because over the course of a summer, from one summer to the next, you have a winter, you have the opportunity for salt to be used to clear ice and snow. That gets down into our system because most of it's underground, a network system. And that can corrode and impact our equipment. We have certain equipment that is starting to age, and we anticipate that we have a cycle for replacement, but the conditions that it was experiencing over that course of the year might be different than what we anticipated. So we will take a look at what we think will be a problem area, and we'll try and address those before the next summer comes up. But when we have what we call the first burn, that first heat wave, that's a concern where things will pop up and we'll see areas that were just fatigued or corroded or something happened there, and we're going to have a failure. We can't prevent that failure. It's going to happen. We do the best we can to try and prepare for it, but it's going to happen. So the next thing that we do, and we're actually doing that right now, as part of this study, we've determined that if we can put in interrupters in our system, and what that does is if you have two lines of power going out to different areas from a station, and you have a failure on one, you want to make sure that you don't keep putting power out to that area, because that just complicates the damage that's going to be done at that area. So you want to interrupt that. And that way you can isolate it, and then you can deal with it and possibly get it back faster because there's less damage done. The other thing is you want to prevent that, if it's a short or something like that, you want to prevent that from then affecting the other line that's going out. So you want to make sure that you isolate that so that you can prevent cascading effects of this going forward. So we've come up with solutions that react to heat, anticipating that we are going to have failures. We're doing the best we can in terms of our designs to make sure that we no longer have those failures, strengthen some of our connections, change the type of cabling that we use. But that takes time. And in the meantime, you have to make sure that you've prepared the system for any other heat.
Thank you, Charlie. Let's go to you next, Roop, with that question about opportunities and challenges in the heat resilient space.
Yeah, absolutely. This is probably going to be a bit jarring after hearing about the very specific needs of Con Edison. I'll talk a little bit more about the broader challenges and then maybe one opportunity. We know from the latest IPCC report that extreme heat is regionally potentially a tipping point, and the reason why is a lot of regions in the world are not adapted to or don't have adaptation plans in place or sufficient adaptation to deal with the changes that are already here and coming. And so an example of that is if you look at where do we have city heat action plans, majorly it's in the United States, North America, Europe, Australia, some in India, and parts of China, I think, are starting to build these plans. But if we look across Latin America and the Caribbean, very few countries have these plans in place. In Africa, maybe 2 or 3 cities that I'm familiar with that have city heat action plans. So the scale of what we need to do is huge, and the time that we have to do it is very small. So that's absolutely a challenge, but not an insurmountable one. The other one that I want to mention is, along with the trend of climate change, urbanization is one of the biggest trends we're seeing globally, right? More and more people are moving into cities, and oftentimes they're moving into these informal areas that are not the formal buildings or skyscrapers or places where more affluent people live, but rather in places where perhaps their homes are not well insulated to be able to withstand extreme heat or even other types of hazards. They join the informal economy. And oftentimes when we are building policy or adaptation plans, we're not including this sort of huge informal sector. And that's something that I think we can absolutely take into account, but it's something that we need to focus on more, especially with our research. We can't just be researching what's in the formal economy and the formal sector, but also include this huge informal space. One example of this, we did research in Kenya where we looked at their threshold for extreme heat. And basically, the Met Service was using a station that was near the airport in an area where it was cooler. When we looked and put temperature sensors in some of the informal settlements, they were regularly reaching the extreme heat threshold and beyond it more often than the temperature sensor that they were using to issue heat alerts. And so in knowing this, taking this into account is something that I think is really important. The opportunity space that I see is also huge. So one of my colleagues did a piece of research that showed that there's 5 billion people around the world that live in a place where we have either seasonal or weather scale predictability for extreme heat. So we can, for example, build early warning systems to cover those 5 billion people. But we need to be able to have the science to back it up and then the practice to actually take action based on those warnings. I'll leave it there.
Thank you, Roop. Franco.
Sure. I'd say for me, as an engineer, again, I'm always thinking about designing things. And I feel like one of the challenges is a mindset that's focusing on sort of demand management in terms of heat, right? Air conditioning, more air conditioning, which I think, is problematic from an equity standpoint, but also from an infrastructure standpoint. I mean, from an equity standpoint, in the places where I work, in inner city Philadelphia, inner city New York, there even, people may not have air conditioners. If they have air conditioners, they may not want to use the air conditioners for so long because the power consumption and the economics associated with that. And then more air conditioning use, of course, opens you up to a different vulnerability to power outages, for example. And so, you see buildings that are built with non-operable windows, then what happens if you have a power outage? And so I'm more interested in, what the IPCC is calling climate resilient development, strategies that have an adaptation value, but they also are situated within a mitigation context, right? And they're also addressing, whatever happened to the sustainability goals that we had. I mean, in real neighborhoods, people have real needs that extend, include and are accelerated by climate change, but include a whole bunch of other things. And so I see, an opportunity and a challenge is our creativity in coming up with solutions, so ways that people can cool, that are consistent with the other goals that we have in terms of limiting energy consumption, and advancing or improving our cities, improving our neighborhoods, improving our buildings, improving our ability to sort of have a decent quality of life in a city, in a built environment. And people like to talk about just throwing more trees. We need trees, of course, but then you have to think about how do you get them into spaces where they actually reduce exposure to heat, and how do you think about these types of opportunities or these types of solutions, considering their relevance and their need among different sectors of the population. So to me, I just see air conditioning is, of course, necessary in certain situations, but I would love to see more creativity in terms of other approaches for providing relief of extreme heat in especially cities and the neighborhoods that are most vulnerable within them.
Thank you, Franco. Yeah, great to hear you bringing in the emissions reduction component to all this and just broader sustainability and sort of justice and vision and goals. And it'll be great. Charlie, I know we'll want to hear from everybody on these things, but I know you and a lot of your scenario planning, we can get to this later, are trying to project, how the grid may change in terms of the sources of energy and sort of broader assumptions about new building and such too. So that's interesting. But let's sort of stay with this here now. And Dan, hear a little from you about some of the main challenges, opportunities, and in heat resilience.
Yeah, I want to start with a couple of opportunities I see. And the first is that this is obviously not true of every kind of adaptation intervention, but for some of them, like reflective roof coatings and pavements, they can be done in a way that's deployable very quickly in a time scale of weeks or months, not years. And I think that's not true of all forms of adaptation. Things like coastal retreat and like hardening infrastructure will take a lot more time. And I want to acknowledge what you mentioned too, Roop, and say too that the ability to do any of this in a rapid way is a sort of privilege. But at least in some cases, there are adaptation measures that are available that can be done very quickly and see very real benefits in the very near term. And that also makes the economics of it advantageous, so there's sort of momentum that can be built there. And it avoids some of the harder questions around how do we account for intergenerational equity and who of us will pay for this and discount rates and all of those kind of more complicated things that have to factor into conversations about adaptation that will take decades to realize. A second opportunity I see is that sort of for the co-benefit reasons that we've talked about, this area is really ripe for coalition building and bringing in expertise and resources from a lot of different organizations. Health departments in cities are great partners for nonprofits in those cities. The scientists can partner with, folks who are interested in stormwater management and bring in a lot of different resources together that are ultimately maybe coming at it from slightly different angles, but in the synergy of that, be producing really powerful adaptation measures. And a third of those mentioned quickly is, at least right now in the US, there's a lot of money flowing through the Inflation Reduction Act out to nonprofits and cities around the country. Obviously, we have an election coming up, and that money may not continue to flow in the same way. But for the time being, and even with the money that's already committed, there are resources flowing out that are helping with that. And so I think there's an opportunity right now to take advantage of that and maximize on that while it's available.
Great. Thank you, Dan. I think some of your comments, provide a nice pivot towards our second question. What are some of the needs from the science community? Doesn't need to be just, physical science. Could be social science in the sort of transdisciplinary space that you all have already sort of pointed to in various places. What are some of the needs that you see in terms of information? that can help us be more ambitious in our heat resilience. I'll start with you this time, maybe Roop. We'll just, yeah. Okay.
Absolutely. So I wrote down a couple, and I want to share them. One area that we want to focus on more is on indoor heat in particular. So there's a lot of work that's happening using ambient air temperatures outside, but really what affects people, and oftentimes where we see the most heat-related mortality, is because of the temperatures inside buildings, inside people's homes, inside the places in which they're working. And so I'd love to see more research focused on indoor temperatures, indoor temperature thresholds, so that we have a better understanding of the environment in which we really start to see some of these health impacts. So I think that's very important. The other one is around behavior change research. Just telling someone that, hey, the heat is potentially deadly, is not going to stop them from actually going about their daily life, right? So how do we speak to people in a way that helps them understand their own personal risk? I remember there's a study out of the UK where it talked to people who were elderly and taking medications that clearly were at risk of extreme heat. And in this study, they spoke to these people and they told them, hey, because you're taking X medication, it's going to actually increase your risk. And then a little while later, when they talked to those people again and they said, are you at risk of potentially being affected by extreme heat? They were like, no, I think it's all of those other elderly people who are more at risk. And it just speaks to how oftentimes we just don't think of ourselves as personally being the people who we're talking about. So how do we come up with strategies to really be able to talk to people so that they understand their own risk and what they should be doing? Because a lot of our work is volunteer-based. It's one-to-one talking to people. And so if we're doing a door-to-door visit, how can we be more effective at ensuring that we're keeping people safe? That would be really nice.
That's great. Thank you, Roop. We have our communications panel tomorrow. It'll be interesting to see to what extent some of those deep and systemic issues you raised are come up in that panel. Franco, to you.
Sure. And I think the last presentation of the session before this was really touched on this point as well. I mean, I think climate scientists tend to look at climate for obvious reasons. You're trying to look at large-scale trends, so you tend to look at gridded data products. You tend to use weather stations that are, deployed in appropriate locations, which often means airports. And that have historical records that are long enough to discern trends, et cetera. And so you get this sort of broad course, temporal, broad spatial representation. But what I see on the ground is that data doesn't necessarily tell you what's happening in specific neighborhoods in front of a specific house. I'll give another example from the water field, right? We tend to talk about this was a heavy day, a day of heavy rain. It was a lot of rain over 24 hours. That doesn't necessarily tell you that it's going to flood, right? If you have a pulse of rain over 5 minutes in that day that exceeds the ability of the drainage system to sort of take that water away, you're going to get a flood. And the same is true, I think, with heat. That you could have peaks in temperature, peaks in humidity, peaks in radiation. My group is doing some work right now on top of the Javits Center, trying to understand differences. There's a farm on part of the Javits Center, and one section has a lot of reflected radiation from skyscrapers, and actually we can see lower crop yield in that part of the rooftop farm than in another place that's more shady. So if that's crop yield, think of the impact of walking down a street. Streets tend to have different orientations. North-south streets, you might say, because of the orientation of the sun, have a greater percentage of the day. This is a hypothesis when, they're shady than an east-west street. So does that mean that you would tailor a heat mitigation strategy that's impacting pedestrians differently on an east-west street than a north-south street? think about where you plant trees in a city. Is there more value if you have a limited budget to invest in tree planting? Is there more value to putting trees in certain urban configurations? You can't make these kind of tailored local adaptation decisions if we don't have microclimatic data at the temporal and spatial scale that is relevant to addressing the needs of communities. So to me, that's that's part and parcel of trying to insert adaptation ideas or scale adaptation ideas inside this sort of broader mitigation context, so that we're not just throwing the same air conditioner at everybody's house in every location. We're looking for ways of doing things a little bit differently in different places.
Just thank you, Franco. The Javits Center, for folks who don't know, is a building in sort of Midtown Manhattan that has had a green roof for a long time, and I think a long history of sensors and various readings that Franco and others have been involved in. Dan, to you.
Yeah, first of all, I just second what you said, Franco, that the really specific street level, block level data is probably the number one thing, is the number one item on my list. But close second to that is robust, defensible data on how adaptation interventions have worked in real-world situations. And I think that's needed to tell a compelling story to funders, to investors in a lot of contexts. The modeling is important and it's critical for siting projects and designing projects, but understanding how things have worked, especially in a backward-looking way, I think would be a really, really powerful tool for nonprofits, city officials, other elected officials to understand where resources should be spent and to be able to feel confident that that money is being spent in a way that is effective and is going to make the real difference they're looking for. And the other area I would mention too is that in a lot of the literature I've seen translating science for policymakers, there's a focus on averages increasing over time and the kind of gradual increase, and less so on making accessible information on the kind of compound concurrent events that we're talking about at this conference. And the planning is similar in some ways, but I think there's a need for materials that are understandable by folks without a deep climate science background on how to think about those really extreme events and record-breaking events and how to manage limited resources in the context of needing to be prepared for those as well as the kind of softer peaks, I'll say.
Yeah, thanks, Dan. It's great to hear you really sort of engage us around the science and physical science, social science of evaluating adaptations, right? It's partly about, did you actually get the climate response that you expected, but also more mundane or at least different things. Did a project come in at cost? Were there unintended consequences? And it even circles back to the climate science when we think about attribution. Do people even sort of articulate what level of storm, for example, an adaptation was intended to address? It actually becomes kind of a non-trivial question to say, did it meet its intended goal? Because, in what ways was that next storm similar to, different than? And compound extremes, as you note, opens up a whole nother level of complexity and these questions about saying, what do we mean by successful adaptation and the testing and evaluating of it? Really interesting. Charlie, okay, what are you going to tell me about what you need
well,
the scientific community or more broadly?
Well, I'll tell you, I listened to a lot of the presentations this morning. All of them went over my head, but I was constantly interested in how that would apply to my projections going forward. How more confident can I be in a heat dome coming up based on precursor conditions coming forward? Should we anticipate something that's going to be a long heat wave, or is it going to be a typical 3-day, maybe 2 or 3 day or 4 day heat wave? Understanding that, and as Dan said, is putting it into layman terms. That was the big struggle for Radley and I. When we first got started, I didn't understand, what does highly likely, most likely, very likely mean to me, an engineer? I need to know how many days is it going to be over 95, and if that's going to be 3/4 or a third of the summer, then how many times am I going to have those days coincident? And then the other thing comes up with compound events. What other event might happen? If you're going to have a major heat wave and then you're going to have a cold front come through, you're going to have some thunderstorms, that's another risk for us. So we need to anticipate what those things are. The science, I see the science is really trying to understand what the climate is doing, where it's going, what the weather patterns are going to be. And I'm very interested in how you're proceeding. What I want to know is, what does it tell me when I'm trying to figure out in the next 5 days, what's the weather going to be? In the next 20 years, what's the weather going to be? Because I need to make sure that our equipment, some of it we can do on an annual basis, like on heat waves, we anticipate where we may have aged equipment where it might fail on a high load day. So we anticipate that and we try and fix that the year before. But when it comes down to a substation, flooding a substation, we need to know years in advance so that we can anticipate how we're going to design that flood station to take care of the flood and put that in place. It takes a couple of years to actually do this work, and it depends on where things are going. Another thing I need you to think about is we see a lot of electrification in our future. And in electrification, a lot of pushing electricity creates heat. So how does that factor into some of your analysis? When it comes to understanding local events, downscaling the climate science, after we did our first study in 2020, we actually installed weather sensors around our system so that we can get more granular impact. And we're only 3 years into that data. It's not enough really to get stuff, but it does show us that we do have urban heat islands in our facilities, in our networks. And so that gives us a better sense of, if you're starting to tell me this is, heat's going to be coming in 10 years earlier, that means those urban heat islands are going to raise up a lot sooner. I can't deal with the internal temperatures, but our main thing is, how are we going to act on the ambient temperatures? That has the biggest effect on our system. So a lot of keep doing what you're doing. I just want to be able to talk to you guys and get a better sense of what does that mean to me in the future in terms of actual numbers and actual projections, turning into forecasts maybe. Yeah. Hard answer.
And Charlie means that he was at a workshop that Colin Raymond, probably in there, organized here with me and some others, deep on correlated extremes 5 years ago now. I think over 5 years ago, you were there listening, and probably to some extent some of the things being discussed there about, for example, compound tropical cyclone risk and heat are things that I think you pushed for in some of the work after that, if I recall correctly. So part of what I hear there is, of course, we want the quantitative, we need the quantitative where we can, but part of resilience is also, especially as we think more about compound risks, is finding ways to engage the qualitative and accept maybe some of those levels of uncertainty, especially early on.
The closer you could come to quantitative information, that's really what we're looking for.
Yeah.
We understand it's a hard task, but we're looking forward to that. I go back to thinking about weather forecasters. When I was a kid, they had, they were telling you maybe tomorrow you might see some rain. Now we've got 10-day forecasts going out. So I know that progression should work as well into the climate community.
That's a challenge to a lot of us, right? Okay. Franco, you want to jump in on that?
Yeah. I was just involved in a study to look at flooding in New York City, impacts of climate change in certain places. And one of the things that was really interesting is we took a storm, a storm quantified, in terms of 5-minute intervals of rain, and we applied it to a prototypical street. And you see flooding, right? And then you apply mean sort of delta changes to that to look at the future, and you see more flooding. But if you don't apply the delta change and you just look at a different distribution of rain during that day, you in some cases get more flooding than you would have compared to the application of some kind of a climate change factor to this historical storm. So the variability, I think, and I think this gets at what Charles is saying, that the variability in even present day conditions, it gets to that temporal resolution, is really important, because once you exceed certain thresholds, you could have a flood, you could have a power outage, you could have someone not being able to go outside, you could have a death, right? So, that's, I think, just drilling in the temporal variability question, I think, is really important.
Great. Thank you, Franco. Okay, so we're doing really well on time. I think we're going to have a chance to take a lot of audience questions. We're also going to, I think, be able to go onto the Zoom if there's some questions there too. But before we do that, let's go around and hear this sort of short elevator pitch from everybody. I think what we most want to hear here is something inspiring, something about how to, I mentioned a little bit about tipping points in the solution space, sources of optimism in light of all the negativity we're seeing around rapid expansion of heat and impacts. Where's something where you see sort of hope that we can galvanize, leverage, use technology, use people to maybe move the heat resilience envelope forward faster than people might think, and or something that might surprise us. You know, if you'd rather sort of go in that direction, feel free to do that too. But I think ideally something that might surprise us in the space of how could heat resilience improve a little faster than people might think. So I think with our sequencing, do we start with you now, Franco, I think, on that question.
I mean, something.
Let's keep these kind of short. Sorry.
Sure. So something really surprising on the blocks where we put these shade structures is that the community organizations that we worked with said that they got increases in requests for other things, social services, educational services, requests for trees on those blocks compared to significant increases than compared to other blocks. And I think that just speaks to the possibilities of building resilience, broadly speaking, by thinking more holistically about how we address some of these problems. I don't think we have the liberty to think about a heat problem, a flooding problem, an economic problem, a workforce development problem. We just don't have enough resources and programs and government agencies to think about these individually. We need to sort of come up with these hybrid, multifunctional solutions that do many things in one place. And then what you start to see is that the sum is greater than the parts because you build trust, you build social cohesion. There are cascading effects where mitigating a climate hazard has a health impact. It has an economic impact. And so, to me, that's how I stay optimistic. Is this idea of thinking not about co-benefits, because that suggests you're doing one thing and getting a couple of little other things, but thinking broadly about multifunctional sort of strategies that are derived from the science, the science that tells us where the hazards are, but don't pretend that communities just have one need when really we have a whole bunch of needs that we have to address simultaneously. So I really like to see all of this in that broader context of solving problems.
It's fantastic. I'm glad we're recording this session. That's phenomenal. Thank you. Over to you, Dan. Same question.
Yeah, two responses to that. Maybe not exactly on point, but two responses to your question. The first, speaking strictly for myself, not any organization I'm affiliated with, I think that we're in a legal moment where we shouldn't be putting all of our eggs in the basket of expecting incremental change from the top down to make sweeping changes that we need to address the climate crisis. And that's a challenge, but it also means that the importance of private sector and nonprofit action is more than ever. And so I think that there's a real opportunity there because there's a tremendous energy and interest and resource there to make real change. And to try to, on a slightly more optimistic note, with a little bit of a dark underbelly, one of the analyses I saw was that a suite of smart surface interventions for a major U.S. city would produce a 10-to-1 benefit-cost ratio. And the hard part about that is because it's an indication of how far we're locked into patterns of development and urbanization that will necessarily incur huge costs in the future. But there are ways to dramatically lower those costs with tools that are already in hand, already exist today, and are proven. So I think that's something that surprised me and hopefully is exciting to continue this work.
Was that sort of like, can we think of that as kind of like a dollar invested in the right space can give $10 in benefits?
A dollar today to avoid 10 down the road.
Avoid 10 down the road. Thanks. Okay. Charlie?
So one of the things that I find interesting right now that I'm seeing that is the infiltration into our day-to-day lives of climate information. So I'm now seeing the weather people talking about heat index, and that's good because we always had wind chill factors and people understood that. But now with a heat index, that becomes an opportunity for science to get more information out into the public as to how this is going to work. So that's one way of I see going forward is getting that out where it's accessible to the general population. And this, it's getting a lot of attention. The other side of it is it's collaboration. It's working with other organizations. So we keep in touch with all the different groups municipalities that surround us, that we're involved in, our largest customer in New York City. We try and make sure that we're aware of what they're doing in terms of addressing climate change, so that we make sure that we're not conflicting. It's okay to overlap, probably don't want to overlap too much, but you can't always rely on somebody else to fix your problem. You got to make sure it's fixed on your own. So we do focus on that, but we do want to make sure that we're not going to create a problem for somebody else in the industry. So a lot of collaboration is very important in going forward. And I see that as we do this with our developments, working with our working groups, keeping our constituents aware of what we're doing, why we're doing it, what the climate is telling us, and translating it for them to say, this is what it means in terms of the equipment that we have to put in place, the protections we need to install. And yes, that costs money, but we're on a path where we can't avoid doing that. You need the electricity. You need it more and more in the future as electrification happens. We have to make sure it's there. We don't want to be creating outages on a regular basis. So this is where the climate science, giving us better information to work with, helps us to prepare for the future.
I think as a sub-point there, I hear also an opportunity to share risk communication with right down to the individual level in the household, including some folks who maybe historically haven't engaged around climate change.
And I guess one of the other things is one benefit that we found when the law was passed, where the electric utilities had to do a resilience plan like we did, is we worked off of one common set of data, the climate data that Columbia University was providing with us, CMIP 6. So we were all working with the same information and how that was going to impact us. So then you had a better sense of how, as you cross a border from one utility to another, how that might interplay as to what you're doing versus what they're doing. And that would be ideal if we could do that across the nation, but getting a better sense of what is the common trend going forward. We will always probably design slightly above that trend, because trends are averages and there's always fluctuations. So we got to make sure that the higher end is taken care of. But having that ability to pull people together on one trend and one view of the future would be helpful.
Great. Thank you. Roop.
I guess the thing that I would share is the importance of this collaboration between science and practice and adaptation. I want to share a story of my experience with this. So about 7 years ago, we were like, we need to work on extreme heat. This is an issue, and how do we do it? So we collaborated with actually some scientists at the public health school here at Columbia, and we were focusing on Bangladesh in particular, and there was this 8-day period of extreme heat in Bangladesh. And through this collaboration with these scientists, we figured out what was the level of excess mortality during this particular heat wave. And it was huge. It was over 2,000 people who, according to our study, who had died because of this extreme heat, right? And so we were like, okay, we really need to do something with this information. What could we do? And so we decided that we were going to go to the Bangladesh Red Crescent and present them with this information and talk to them about what they could be doing on extreme heat to reduce some of this mortality. So I went to Dhaka. I was there for a different workshop, but I talked to some of the leadership at this national society, and I showed them the data. And they understood the data, and the leadership was a little bit iffy. They were like, you know what, we're really interested actually in cyclones because that's a huge issue in our country. And of course, it absolutely is, and it's something that they do focus a lot on. They were also interested in working on cold waves. So they were like, this heat thing, like we're a hot country. It's something that we deal with all the time. We're not quite so sure. But we kept trying. We had a couple of different workshops, especially with the volunteers in that national society. And we started to sort of figure out what was their perception of heat. So a lot of the volunteers, I'll never forget this, they said things like, the heat is in our blood. My father was a farmer. He worked in the heat. It's something that he's used to, right? And so that was really the thing that they thought of when they thought of extreme heat. They weren't really able to see the numbers in their experience, right? But then we sort of delved in a little bit deeper, and I asked them to think about, what about the rickshaw pullers? What about the people who are roadside vendors during the extreme heat? What about your elderly grandparents or parents right now who might have diabetes or high blood pressure? Have you seen what the impacts of extreme heat can be on those people? And when we started to explore that in a conversation, that's when we started to get these stories. They were like, yeah, my grandfather last year, he collapsed during this really hot period. He didn't have enough water during that time. We started to hear more and more of these stories, and it started to become more real to them, to be able to connect what we saw in the numbers to their own experiences. And it's through that continued engagement that I think we can really start to connect the science to the people and what do we need to do about it.
That's great. And fast forward, and I think Dhaka now has a heat resilience officer, Bushra Afreen, who unfortunately couldn't join the panel yesterday in the end, as I understand it, largely because even though it was late in the evening, she was dealing with on the ground, resilience challenges in Dhaka. So in a way, that's a full circle, I guess. So we now have time for audience questions. Let's start applauding the panelists a little bit now as folks line up and ask questions. So yeah, questions welcome here. I'd say we have about 20 to 25 minutes. Do your best to really make sure you're asking a question, more than talking. To the extent we can, keep the questions kind of short. Likewise, the answers. Not everybody should feel like they have to answer each question, too. Okay, I saw you first. Go ahead.
No, ladies first.
Okay, please, yeah. And please say who you are at the beginning.
Sure. Hi, my name is Jennifer McDermott. I'm on the climate team at the Associated Press. And I was actually curious about the park benches and kind of what happened with that program. It seemed like you were testing it as a potential, climate or heat solution. Did you find that it is? Were you collecting temperature data? And is it cooler on those blocks now? What did that show you? And if it is a good heat solution, are there any plans to expand it?
Yeah, thanks for the question. So we have been collecting data with community civic scientists, is what we've been calling them. And we've also installed weather stations where we can measure wet bulb globe temperature in 4 different neighborhoods. And then we've got mobile sensors that can measure wet bulb globe temperature, and we have groups of people as we speak in the middle of every day walking around these neighborhoods and doing transects. What we've found so far, this is sort of unpublished, we're still analyzing the data, but what we have seen is that there are big differences in heat from block to block and from neighborhood to neighborhood, and we've seen some differences based on, interestingly, we found that diagonal streets are sort of unique, and the north-south and east-west streets are kind of in the same category. But the project was funded by a local philanthropy, the William Penn Foundation. They funded initially 1 block, then they scaled it up the next summer to 5 blocks, and then we scaled it up to 4 neighborhoods. And we just put in 60 this past weekend, 60 additional planter benches. And I'm now talking and hoping to get additional funding. And I've been talking to, this is not a commitment or anything, but I've been talking to decision makers within city government about how this might overlay with other things that are being offered. For example, the Pennsylvania Horticultural Society gives out trees, and the Philadelphia Water Department gives out rain barrels. And how could we insert these shade structures into sort of a family of things that are decentralized, call them resilience broadly, measures that you can do in different neighborhoods. But we've employed, we've had full-time work for lots of individuals over the last 4 summers doing the fabrication, and the data. The data collection hasn't been full-time. But yeah, we're trying to expand. We're looking for funding actively to try to expand into other neighborhoods and even other cities if possible.
Great. Okay, over here.
Hello, I'm David from Sports Technology, and if anybody would like to improve their tennis game, see me later. So I want to bring up a couple of issues. One is the air conditioning and poor neighborhoods. So why not have the people open their doors and windows and get cross ventilation, which I think is relatively free vis-a-vis the cost of air conditioning and the Con Ed bill. The other thing is that in a lot of apartment buildings, particularly smaller buildings, where older people on Social Security cannot afford air conditioning, if you opened up the stairwell shafts and had people open their doors and windows, you would get, again, cross ventilation, which is relatively free. So my last question is about Google's announcement about 2 weeks ago that they're not going to meet the 2030 goals that they had stated in terms of zero emissions. And with all these data centers using a lot of juice, particularly with AI, we have the need for electricity to run the data centers, which you just said causes heat. So it's kind of a vicious cycle, even if you have efficient chip technology. So maybe you could address those issues. And
Thank
the
you.
last thing
I got to cut you off there.
Okay.
Thank you, though. That's
the
helpful.
last one is the Bitcoin mining, which is greed.
I think that's one that we can broaden through this overall context of more electricity uses. Let's sort of combine those first two questions, which I sort of hear as non-AC opportunities to cool or ventilate a bit at the building scale. And then if Charlie or anyone else wants to speak a little bit to some of those dimensions that were mentioned at the end of sort of other aspects of electrification. Do you start with anybody who wants to? Yeah, okay.
Well, I like the idea that the cross ventilation. I'm just thinking in my own experience of seeing some of the buildings that people are living in. It takes a cooperative effort in the building to do that. So if you've got a six-story walk up, number one, are the windows even able to open? And then are the people comfortable leaving their door open in that building? You know, those factor in. So I think it's a great concept, but I think it's something that needs to somehow be organized. When it comes to, energy, as I said, pushing energy does create heat, and those sites do create heat. But we not only are those coming forward, but we're also electrifying our vehicles. We're electrifying our heating. So we're moving towards that as part of a greenhouse gas emissions. And hopefully the energy that's being produced, we only distribute, we don't generate. So hopefully the generation is going to be from renewables, and hopefully we can match that up so that you're not having problems meeting your loads. So, I mean, that's the best I can answer for that.
Anybody else feel like they'd like to speak to some of the non-AC dimensions of cooling buildings or the electricity parts of the question?
Yeah, I'm very interested in those ideas. There are also really traditional ideas that are done in different places. I mean, shade itself is really interesting. But, I will just say on high humidity days, the ventilation doesn't necessarily give you the respite that you need on certain situations. So I think, these types of solutions, you need to have them so that you can generally use air conditioning less. But some of the extremes that we're seeing of temperature and humidity together create the need for other options in some situations.
And one thing in our working with the city's working. They have a climate community resilience effort out there where they're working with different areas to try and find out how best to address climate change in those communities. And one of the things that they're looking at is resilience centers, where you'd have a cooling center capable where maybe they can't stay in their own home, but they have the opportunity to get respite at a cooling center. And we want to make sure we understand where those are going to be, because we want to make sure that we're trying to make sure that delivery to energy to those facilities is not interrupted unless absolutely impossible to prevent. So, these are the things that I know the city's doing, and we are in support of that in the way that we can.
And I'll add quickly on that too, that some of the research that we've seen is that there's synergistic benefits between having some of these technologies like a green roof with solar panels can increase the efficiency of the solar panels because the ambient temperature around them is lowered. Having a cool roof can lower the air temperature on the roof, where, at least in larger buildings, the air conditioner intake often is, then reduce the need for AC. So I think we would look at the whole suite of solutions, and even where air conditioning still needed to get the indoor temperature to a livable level, that there's opportunity to kind of combine these in a way that serves the interests of both.
Let's go over here. Yeah.
Hi, I'm Luoxu from Princeton University. I'm working on energy system resilience, especially for tropical cyclone and the heat wave impacts. So I have a question. I have actually two questions for Charlie. So the first one is, I was wondering, what kind of hazards is Con Edison worried mostly? I mean, for heat wave alone, it may be not dangerous for Con Edison power grid, because you still connect to the PJM, and you still have the fine local distribution networks. There's no damage, so you still have enough generation capacity to supply the electricity. And let's assuming everyone has AC, so I think the work I'm working on is the tropical cyclone and combined with heat wave. So the tropical cyclone may disable the generation capacity and break down the distribution lines and cause the power outage. It happened for, you mentioned, Hurricane Sandy, and they also happened to Hurricane Isaias in 2020, I remember. So do you think that's the most dangerous thing to Con Edison? And my second question is we are going forwards to net zero transition, and we integrate more and more distributed renewables like the solars. Right now, as far as I know, if you disconnected your household, disconnected with the grid, your solar panels still not usable. So is there any plan the combined with storage to improve the local community resilience against the climate streams, when this household or the local community disconnect from the main grid?
Great. So we'll start with Charlie there. Sort of first question, I think, sort of what keeps you up at night,
right.
maybe especially to what extent does that hurricane compound with heat keep it? And then the second question about, I guess, as I understand it, sort of how independent and offline is solar in the end given back. Let's go to Charlie majority here, but afterward, I'd love for others with different context to weigh into.
So your second question first, because I'm not an expert in that area. There are efforts to try and determine how distributed energy resources could be utilized within a system. So there's investigations, there's work on that area. They're trying to figure out how that be done. Battery storage is another part of it. So there's a bunch of different opportunities to bring power in, compensate for the solar and the wind ups and downs, and also just making it a better situation where you have a more reliable source. When it comes to what keeps us up at night, storms are, major extreme events are really the problem. When you have something very extreme, yes, heat waves we're concerned about. We haven't experienced a 10-day heat wave yet, so I'm not 100% sure what impacts that might have on the system. The shorter ones we understand, we can prepare for. One of the things that we don't like about having to deal with heat waves is we have to now focus on being prepared to respond to any events that might happen on the system. It sort of takes some of our staff away from doing normal business to try and grow the business. So that's one thing, but it's the storms, the biggest ones, are our biggest concerns. Wind is a big issue. We have a very strong network in the Manhattan area and parts of other parts of Bronx and Queens. And we have N-2 contingency levels in that area. So we can have some failures based on different things. We're very comfortable we can recover from that, but we are always cautious when something has gone down, and we have categories of incident command structures that we put in place based on how much contingency we have left. But it is storms. Most of what's happened is up in the Westchester, Orange and Rockland territory is wind damage.
With the above ground.
Above the radial, above the aerial wires. Always is a problem, trees always coming down. As much as we try and keep our areas clear, it's a big problem.
Right. Thanks, Charlie. The question was sort of to Con Ed, but I think it's an interesting one to see if anyone else wants to weigh in on, either dimension. What's the scenario that sort of worries you the most, sort of keeps you up at night, and or anything you want to say about microgrids, distributed energy, and storage? Anyone want to jump in on that?
Maybe from a disaster response and emergency perspective, the scenario of a hurricane followed by extreme heat is something that we've really been thinking about, especially in the U.S. context. I remember a couple of years ago, I think it was Hurricane Ida in Louisiana, where we had a similar scenario, and more people died from the extreme heat after the hurricane than because of the hurricane itself. I don't think our disaster response and emergency systems are prepared for that. We don't typically have enough generators, and we're not really thinking about that. But it's something that we're starting to plan for.
Sorry to interrupt you, and the generators might not last long. So keep going.
Exactly.
Yeah.
No, absolutely, exactly, and it's the case right now with Hurricane Beryl in Texas as well. So definitely, this is the place that we need to start thinking more on these compounding hazards.
And I'll just add that, and that's where I think, back to science and what science can do, the more scientists engage with stakeholders to find out, people on the ground know what will happen. Well, if I didn't have that, then I couldn't do this, then I couldn't do that. It's hard to infer those things broadly without talking to folks like Charlie or talking to even, at the community scale. I mean, you talk to certain people, and that when the energy goes out, then they can't get to work. They can't get to, there's all these sort of cascading set of crises that come from one crisis, and it just sort of speaks to the importance of engagement in this work.
Yeah, and sometimes it's hearing about the near misses in the past too. What if it was slightly different, either on the climate side or some other aspect of the system? It's informative. Okay, we got about 10 minutes. Let's try to go. This is great. We got 3 more questions. Let's try to go maybe just like a little bit quicker, but this is basically working. Deepi, let's go to you.
Okay, this is a question for Roop. It's actually from one of our speakers earlier, from Samani Sengupta, who's online, and she's asking, you mentioned earlier that, the behavioral changes, if you're just telling people once about the health risks and that's ineffective, what actually is effective in enabling some kind of behavioral change and responding to and taking heat risks seriously? And if I can add my question, which is related there, we talked about compound hazards here in the US, but in communities elsewhere that you're working in, what sort of heat-related compound hazards have you seen as being challenging to deal with?
Yeah, absolutely. It's a great question. We've done a bit of research around how can we communicate better, and one of the things that we found to be effective is if you remind people of a past heat episode that they've experienced and couch your messaging in that previous event, it helps them to be more prepared and sort of be in that frame of mind of, oh yeah, I do remember last summer there was that heat wave, the power went out, it was really hot, we were affected in XYZ ways. Therefore, this summer, I want to prepare and make sure that my air conditioning's working before the heat starts. So being able to remind people of past extreme heat events helps them to prepare for future ones better. That's one example. But there are tons of strategies. We need to be able to enact them more. On your other question about compounding, we've started to see, the interesting thing about heat is it affects so many different parts. So for example, in Honduras, one of the things that we noticed is heat waves were happening at the same time as there was wildfires. And so a lot of people who have asthma or maybe even don't even have any lung-related issues, were starting to see those health impacts because it was both very hot and the air pollution was terrible. So I think in a lot of parts of the world, we're starting to see that more so, especially outdoor workers are affected by that. We also see a lot of impacts on farming and agricultural productivity, right? So lower productivity leads to lots of different changes, also economic changes that affect people's ability to work afterwards. So it's all very connected.
Okay, I guess in the interest of time, let's go over here.
My name's Ellen Castell. I went back to study geography at Hunter College. My background is land use planning, city planning. And I noticed in flooding, specifically, I moved to a block and half the block flooded. The other half didn't. I looked at Wallachia, which you may know in New York City, where they studied the environment before humans came. And I discovered on the other half of the block, there was a creek that ran the other way from my building. So one of the basic questions I have is, I know that in New York City, they're trying to do what I tried to do myself, which was compare the original environment of the world or the earth or the city with what is built and therefore assess risk. But when I'm wondering if that's being done in other places, and also in planning, we initially did studies and we went house to house. This is when I was very young, apartment to apartment, and we looked at what was there and we tried to evaluate it. So I'm wondering if that's being done or being considered in different areas because of the impacts.
Yeah, so I think let's just a minute or two if anyone has thoughts on that. I think even though we're talking heat here, Franco, you have some sort of unique expertise around this issue of sort of water movement and drainage. And then after that, if anyone wants to sort of link heat to this issue of baselines, maybe ambient environments and how the human environment is changing those risks, they can jump in about heat.
Sure, real quick. So, I mean, Eric Sanderson did an amazing job with Wallachia, and I don't know of any other example of that level of detail block to block, but many cities are looking at the historical, where were streams historically, because in many cases, the topographic gradient follows where the historic stream beds are. And so you do get flooding where where water wanted to go. It's still there. There's just now a building. And that's those, I think, a lot of people who study these types of watershed issues understand that, and it's increasingly, I think, to your point, getting into the decision-making. It's sort of similar to what you were saying about going door to door and harvesting local knowledge. It's also harvesting that ecological knowledge that is built into the landscape and its history of modification on top of that. So I think that's kind of where it's at in terms of the physical nature of sort of designing some of these resilience options.
If anyone has any thoughts of sort of linking heat to that, we can hear it. Yeah.
I'll just chime in quickly to say you asked whether people are doing this in other cases. I think this is going on in a lot of places about heat and trying to model down to a very specific, not necessarily an individual house, but a street and the different sides of a street and what the heat impacts are. And in this space, something that may be interesting too is that there are cities doing this for shade as well and modeling at a very high resolution exactly where shading is based on 3D renderings of the entire city and the tree canopy and the built environment and everything. So I think there's an effort to do it, even though it's a huge project and a lot more needs to be done.
Some of it's just sort of on the ground surveys of individuals, right? As you alluded to. Thank you. Okay, last question here.
Thanks. I'll try and keep it short. I'm Dia. I work for Mathematica, and one of the things that we're trying to do is monitoring and evaluation and learning in this space. And a lot of what we're hearing is very similar to what you've echoed. There is just not a lot of evaluation out there to look at the impacts. So I'm curious to hear from sort of the practitioner and implementer perspective, what are the challenges or opportunities to start thinking about evaluation and measurement at the very beginning of a programmatic phase? So when we start to design that and then when we start to implement it rather than that retrospective look back. Thank you.
Anybody?
I'm going to try. I think I can answer that question. What we're doing is in our design process, right? So we put together a guideline based on the climate data that we got. So we've given tables of information to our engineers to say, if you're going to be planning something that's going to live out to this 2030, you can anticipate your temperatures are going to be at this level. Your flood level is going to be at this level. So you should anticipate if you're going to be expecting it to operate in that condition, you should be planning ahead for that. Again, these are projections. So this is where how well it does when it gets to that point, it's kind of hard to determine because these are projections. The numbers are going to be a little bit different. The storm may be coming in differently than we anticipate because climate has changed and made differences to it. So trying to anticipate that we have the perfect solution is not always going to be there. But we do anticipate that we have a better understanding of where it's going to be, and we have a design we think will fit to that. So like when we're our substations and flooding, we're trying to anticipate, as flooding starts to increase and we want to make sure that we are ahead of the level that's going to start impacting our system. That takes a couple of years to plan out and do ahead. Stuff like heat, we can, in most instances, anticipate where we have weak spots based on the age of equipment and its environment when we might have to start doing that sooner. So this helps us understand and retime some of our work.
I can just add that, in the course of my career, our simulation capabilities to look at some of these things have, gone through the roof, right? We can do all kinds of 3D simulations on a personal computer that we didn't even have a personal computer 25 years ago. So we have the ability to simulate all kinds of scenarios. We have increasingly the data sets that we need to create those simulations, but where I see a lack is in the data sets that are used to validate those simulations. And as we all know, models are garbage in, garbage out. And if we don't, so we can simulate all kinds of things in terms of, peak heat areas and peak flood areas, but if we don't have data to then tweak our models to make sure that they're accurate, then even the usage of, we have problems then with the application of those models because we don't know how much confidence to imbue in those simulations. So, back to this need for micro data sets that help us.
Great, thank you. Roop or Dan, anything you want to add on that point? Or?
I'll echo kind of similarly what Franco said, that those micro data sets, but especially as baselines too. And part of the question that I've asked is, well, was this policy measure, so we enacted impervious surface maximums in a particular area, and what was the change? And there isn't always good data on what actually changed on the ground. We can simulate that in some cases or look at it after the fact. But often that seems like kind of a retrospective look. So I think really good, really fine-grained baseline data on existing conditions that can be compared against how adaptation measures have changed the situation would be really helpful to have.
I guess the only place that I would add is we're trying to do that with our risk perception work. So having a baseline of what is the population's risk perception now, spending a couple of years doing behavior change communication and then seeing if that is making a difference. We're doing that right now in Honduras, Indonesia, and Tanzania. So hopefully we'll be able to share in a couple of years.
So glad to hear that those points about behavior at the end as well, sort of linking to some of the humanistic elements of this. Thank you all for a rich, dense session. This was great. Thank you.